Final revision part 2. We're going to talk about fractions as part of a whole. Okay, here we have three shapes. Okay, these three shapes, each of them is divided into equal parts. Parts are shaded and the other parts are not. We're going to have to figure out, write the fraction of the whole amount. Okay, here we have a rectangle that is divided into 4 equal parts. Okay, we have 2 of these 4 parts shaded. So what is the fraction of the shaded region to the whole thing? What is the fraction of the shaded parts to the total number of parts? Okay, how many parts do we have? 1, 2, 3, and 4. So I will make a line. Okay, I'm gonna write 4 in the denominator. Okay, how about the shaded region? How many parts do I have? How many shaded parts do I have? 1, 2, I have 2 shaded parts. So it's 2 over 4. 2 shaded parts of the whole thing, which is 4 parts. Okay, is this the simplified version? No, it's not, because 2 and 4 are in the same timetable, which is timetable 2. That means that I can use the do-do rule to divide by 2, upwards and downwards. To get 2 divided by 2 is 1, and 4 divided by 2 is 2. Okay, you can think of it that way. If you don't remember how to divide, you can think of it that way. 2 divided by 2, which number, if multiplied by 2, gives me a 2? Think of it the other way around. Which number, if multiplied by 2, gives me a 2? It's 1. Which number, if multiplied by 2, gives me a 4? It's 2. So the simplified version, or the simplified form, is half, 1 over 2. Let's look at this example. Here we have a circle, okay, that is divided into equal parts. You have to count the total number of parts: 1, 2, 3, 4, 5, 6, 7, and 8. So we have a total number of 8 parts. So 8 goes down. Okay, what about the number above? We're gonna figure that out. The shaded parts: 1, 2, 3. So I have 3 shaded parts out of 8 parts. Is this the simplified form? I'm gonna have to ask myself, does 3 and 8 share the same timetable? Are they in the same timetable as products? No, they are not. So this is the simplified version. So I'm gonna leave it as it is. Okay, let's have a look at this one. Here I have a rectangle that is divided into triangles, right angle triangles. Okay, I have 1, 2, 3, 4 parts. So the whole thing is divided into 4 parts. Okay, how many of them is shaded? Only 1. Now, is this the simplified form? As long as I have a 1, yes it is. The second topic that we're going to talk about is proper and improper fractions. What is the meaning of a proper fraction or an improper fraction? Okay, a proper fraction is a fraction whose numerator is smaller than the denominator. Okay, just like this one, 2 over 4. I have a 2 over 4. The numerator is smaller than the denominator, so this is a proper fraction. Okay, okay. So if it is a proper fraction, it has to be simplified. So I'm gonna have to look for the simplified. And now I know that this 2 over 4 is a proper fraction. I'm gonna have to simplify it. Okay, 2 over 4. Do they share the same timetable as products? Yes, they do. Which timetable? Timetable 2. So I'm gonna have to divide by 2 above and below. Okay, now we're gonna think of it that way. What number, if multiplied by 2, gives me a 2? It's 1. Okay, now down below in the denominator. What number, if multiplied by 2, gives me a 4? It's 2. So the answer, the simplified form, is 1 over 2. Okay. And what is an improper fraction? An improper fraction is a fraction whose numerator is bigger than the denominator. Just like this one, I have a 5 over 3. The numerator is bigger than the denominator. So this is an improper fraction. Okay, and how do I deal with improper fractions? I'm gonna have to turn them into a mixed number. I'm gonna have to turn it into a mixed number. So I have this 5 over 3. Now I'm gonna have to turn it into a mixed number. How do I do that? We're gonna see. So I have a 5 over 3. I'm gonna have to ask myself, is 5 divisible by 3? No, it's not. So I'm gonna have to look for another number that is less than 5 that is divisible by 3. So let's try 4 over 3. Is 4 divisible by 3? No, it's not. Okay, so I'm gonna take another one out of 5. So the 5, I took 1 out of 5 and it was 4 over 3 and it didn't fit. Okay, what about 3 over 3? Yes, 3 over 3 can work, because what is a number divided by itself? It's 1. Any number divided by itself gives me a 1. So I can split this fraction into 2 parts. One of it will be 3 over 3. Okay, so that means I took 3 out of 5. How many do I have left? 2 over 3. So I split this fraction into 3 over 3 and 2 over 3. Okay? What's a number divided by itself? What's any number divided by itself? It's 1. So the answer is 1 instead of 3 over 3 and the 2 over 3 as it is. Now let's look at this 2 over 3. Is it simplified? Is this the simplified form of it? Yes, it is. Because the difference between 2 and 3 is only 1. So any fraction that has a difference of 1 between the denominator and the denominator is always simplified. Is always the simplified form. Okay, let's have a look at this one. We have a 10 over 7. Is 10 over 7 an improper or a proper fraction? It's an improper fraction. Why is it an improper fraction? Because the numerator is bigger than the denominator. Okay, how do I deal with improper fractions? I turn them into mixed numbers. Okay, we have a 10 over 7. How do I turn this into a mixed number? I'm gonna have to ask myself, is 10 divisible by 7? No, it's not. Okay, let's take 1 out of 10. Now we have a 9. Is 9 divisible by 7? No, it's not. Let's take another one out. We're gonna have 8 over 7. Is 8 divisible by 7? No, it's not. We're gonna take another one. Is 7 divisible by 7? Yes, it is. So I'm gonna split this fraction into 2 parts. Both parts are over 7. One of them is gonna be 7 over 7, and the other, if I took 7 out of 10 by subtraction, how many do I have left? I have 3. Okay, so what's a number divided by itself? It's 1, always 1. So I'm gonna have 1 instead of the 7 over 7, and the 3 over 7 glued to it, or stuck to it. Okay, so the answer is 1 and 3 over 7. Now I'm gonna have to ask myself, is 3 over 7 the simplified version, the simplified form of this fraction? Do 3 and 7 share the same timetable as products? No, they don't. So this is the simplified form. Okay, let's have a look at this one. The last one, 12 over 3. Is this a proper fraction or an improper fraction? It's an improper fraction. How do I deal with improper fractions? I turn them into mixed numbers. Okay, but I have to look closely at this one. 12 divided by 3. Can 12 be divisible by 3? Yes, if I check timetable 3, I can find that 3 multiplied by 4 gives me a 12. So 12 divided by 3 gives me a 4. So the answer is a whole number. In fact, the answer is 4. This is the answer. Okay, now we're going to talk about adding and subtracting. 3 things. First thing is fractions with like denominators. Second thing is fractions with unlike denominators. And third thing is mixed numbers. Okay, let's start with this one. Fractions with like denominators. Okay, we're going to talk about either adding them or subtracting them. Okay, here I have a 4 over 6 minus 2 over 6. Okay, what can be the answer? I'm gonna have to look at the denominators first. Here I have a 6 and here I have a 6. That means that they are like denominators. The denominators are the same. Okay, so I'm gonna stick to this denominator and put it in the answer. Okay, and then I'm gonna subtract the 4 and the 2. 4 minus 2 is 2. So the answer is 2 over 6. Now ask yourself, is this the simplified version for the answer? 2 over 6? I'm gonna have to check timetable. Which timetable do 2 and 6 share as products? It's timetable 2. That means I can divide by 2 up and below using the do-do rule to get the final answer. What number, if multiplied by 2, gives me a 2? It's 1. What number, if multiplied by 2, gives me a 6? It's 3. So the answer is 1 over 3. Second one here, we have 3 over 4 minus 2 over 4. So what can be the answer? Check your denominators. Here I have a 4 and here I have a 4, which means that they are like denominators, fractions with like denominators. So I'm gonna stick to the over 4 in the answer, and I'm gonna only look at these numbers and subtract them. 3 minus 2, the denominators. 3 minus 2. What's the 3 minus 2? It's 1. Okay, is this the simplified version? I have a 1 in the denominator, so yes it is. Okay, let's move on to the next one. Fractions with unlike denominators. How do I deal with fractions with unlike denominators? Here I have a 2 over 5 minus 1 over 3. So I'm gonna check these numbers. 5 and 3, which means they are different, which means this way is not gonna work. Okay, ask yourself, is there a way to turn the 3 into a 5? No, there is no way that comes to mind. So I'm gonna have to use cross multiplication. How do I do that? In 3 steps. First step is multiply the denominators. 3 multiplied by 5 is 15. So I'm gonna put 15 here. Okay, second step is multiplying this denominator by this nominator. This is second step. 3 multiplied by 2, what's the 3 multiplied by 2? 6. Okay, third step is multiplying the 5 by the 1. This is the third step. 5 multiplied by 1 is 5. Okay, what about the sign? The sign goes here. So the answer is 6 minus 5 above and 15 below. 15 is going to stay as it is, and 6 minus 5 gives me 1. So it's 1 over 15. Is this the simplified form? Yes, it is, because I have 1 in the denominator. Okay, let's take a look at this one. Here I have 10 over 12 minus 2 over 3. Here I have 12 in the denominator, and here I have 3. Now ask yourself, is there a way to let the small denominator turn into the big denominator? Okay, how can I turn the 3 into a 12 using multiplication? 3 times what gives me 12? 3 times 4. Okay, that means that I can multiply by 4 here, above and below, using the do-do rule, okay, and keep this one as it is. So it gives me a 10 over 12. The 10 over 12 stays as it is, minus, okay, this one, 2 multiplied by 4 is 8, so it's 8 above, and 3 multiplied by 4 is 12, so it's 12 below. So I have a 10 over 12 minus 8 over 12. See, I managed to switch this fraction, this subtraction, into a like denominator subtraction. So I have a 10 over 12 minus 8 over 12. The over 12 is going to stay as it is. And what's a 10 minus 8? It's 2. Okay, 2 over 12. Is this the simplified form? Okay, 2 over 12. Where do they meet? In the same timetable as products. They meet in timetable 2. That means I can divide by 2 above and below. So that gives me, which number if multiplied by 2 gives me a 2? It's 1. Which number if multiplied by 2 gives me a 12? It's 6. So the answer is 1 over 6. Okay, third and last one, mixed numbers. How do I add or subtract mixed numbers? Here I have 4 and 2 over 7 minus 2 and 1 over 5, 1/5. How do I subtract? How do I solve this subtraction problem? Okay, first of all, I'm gonna have to turn these fractions into improper fractions. Okay? How do I do that? Okay, I'm gonna keep the denominators as they are. So here I have a 7 and here I have a 5 and the subtraction stays as it is. Okay, what about the denominators? Okay, for this one, 4, I'm gonna multiply the 7 by 4, and when I get the answer, I'm gonna add 2 to it. So 7 multiplied by 4 is 28, plus 2, it's 30. Okay, here I have 5, I'm gonna multiply by 2, this gives me a 10, plus 1, this gives me 11. So I turned these two mixed numbers into fractions. Okay? Now I have a subtraction problem with unlike denominators. So, is there a way to turn this 5 into a 7? No way comes to mind. So what am I going to do? I'm going to use cross multiplication, just like I did here. Okay? So, first step is multiplying the denominators. 5 multiplied by 7 gives me 35. Okay. Now second step, 5 multiplied by 30, which is 5 multiplied by 3, and then I add the 0. Okay? 5 multiplied by 3 is 15. Okay, add the 0, it's 150. Okay, what about 7 multiplied by 11? Third step. 7 multiplied by 11. It's 77. And the subtraction stays as it is above. So now I have 35 here and 150 minus 77. Okay, let's do this as scratch work. 150 minus 77. Okay, 0 minus 7 won't work, so I'm gonna have to borrow. This becomes a 4 and this becomes a 10. 10 minus 7 is 3. Okay, what about 4 minus 7? Won't work, so I'm gonna have to borrow. This becomes a 0, this becomes 14. 14 minus 7 is 7. So it's 73 above and 35 below. Now, this is an improper fraction, right? Right. How do I deal with this improper fraction? These are two big numbers, right? Okay. I'm gonna try splitting it. 35 over 35. That means I took 35 out of this 73, okay, and put it over the denominator, okay? All of them are above 35 now. All of them share the same denominator. So if I took 35 out of 73, what do I get? 73 minus 35. Do it as scratch work, okay? 3 minus 5 is, won't work, I'm gonna have to borrow. 13 minus 5 is 8. 6 minus 3 is 3. So it's 38. Okay, if I have 38 now, okay, I can take another 35, right? So I have 35 here. Okay, that means I took 35 out of this 38, so I can subtract again. 38 and I took another 35 out of it. What do I get? 8 minus 5 is 3. What is 3 minus 3? 0. So I have 3 here. Right? Okay, so the answer is, what's a number divided by itself? It's 1. What's another one divided by itself? It's 1. So it's 1 plus 3 over 35, which means it's 2 and 3 over 35. That's your answer. I know this one's challenging, but you're gonna have more than the time you need to solve this one during your exam. Okay, so don't worry about it. Okay, let's take another example here. I have 21 over 6 minus 2 and 1/3. How do I solve this one? I have an improper fraction minus a mixed number. Okay? Previously, I was supposed to turn, if they were both mixed numbers, I was supposed to turn them both into improper fractions, right? Okay, I'm gonna do the same. Since this one is already an improper fraction, I'm gonna keep it as it is. Okay, what about the next one? What about the second one? I'm gonna have to turn it into a mixed number as well. Okay, how do I do that? Remember, 2 multiplied by 3 gives me a 6, plus 1 gives me a 7. So I have a 7 in the denominator. What about the denominator? It is still the same. So I have 21 over 6 minus 7 over 3. Okay? These are unlike denominators, right? Like you gotta ask yourself, is there a way to turn this 3 into a 6 using multiplication? Which number, if multiplied by 3 gives me a 6, it's 2, which means I can multiply by 2 above and below here. Okay, so this one is still gonna stay the same, and this one will become 3 multiplied by 2 is 6, and 7 multiplied by 2 is 14. So now I turned this improper fraction with unlike denominators into an improper fractions with like denominators, which means I can keep the denominator as it is and just subtract these numbers. 21 minus 14. 21 minus 14, do it as scratch word. Okay, 1 minus 4 won't work. I'm gonna have to borrow, so this becomes a 1 and this becomes 11. What's 11 minus 4? 7. What's a 1 minus 1? 0. So the answer is 7 over 6. Okay, is 7 over 6 an improper fraction? Yes, it is, because the denominator is bigger than the denominator. So I'm gonna have to switch this into a mixed number. Okay, this one is easy. Okay, is 7 divisible by 6? Is any number multiplied by 6? Any number multiplied by 6 gives me a 7? No. But there's a number that if multiplied by 6 gives me a 6. It's 1. So I'm gonna have to split this fraction into 6 over 6. Okay, and 1 over 6. Okay, what's any number divided by itself? It's 1. So the answer is 1 instead of this part and 1 over 6 glued to it. The answer is 1 and 1 over 6. Okay, now we're going to talk about multiplying fractions. Okay, we have 3 things here to look at. First thing is if we multiply fractions by whole numbers, if we multiply fractions by fractions, or if we multiply fractions by fraction, but focus on something called cross-canceling. Okay, we're gonna get to that when we get there. Okay, let's take this first case. If we are multiplying fractions by whole numbers, this is very simple and very easy. The whole number gets multiplied to the denominator, and that's it. You keep the denominator as it is, and you multiply the whole number to the denominator. So what's an 8 multiplied by 2? It's 16. So now I have 16 over 3. Is this a proper fraction or an improper fraction? It's an improper fraction, which means I'm gonna have to turn it into a mixed number. Okay. We're gonna have to ask ourselves, is 16 divisible by 3? Do I have a 16 in timetable 3? No. But do I have a 15 if I take 1 out? I get a 15. Do I have a 15 in timetable 3? Yes, I do. What's 3 times which number gives me 15? 3 times 5. So yes, I do. So I'm gonna split this number into 15 over 3 and what over 3? If I take 15 out of 16, how many do I get left? 1. So it's 15 over 3 and 1 over 3. What's 15 over 3? Which number, if multiplied by 3, gives me 15? It's 5. So the answer is 5 instead of this one, and the 1 over 3 as it is. Okay, is this the simplified form for this fraction? Yes, it is, because I have 1 in the denominator. Okay. Here I have 5 over 4 multiplied by 3. Okay, same thing. I'm gonna keep the denominator as it is, and I'm gonna multiply the 3 to the 5. What's the 3 multiplied by 5? It's 15. So I have 15 over 4 now. Is this a proper fraction or an improper fraction? It's an improper fraction, so I'm gonna have to turn it into a mixed number as well. Okay, how do I do that? I'm gonna have to ask myself, is 15 divisible by 4? No, it's not. Okay, if I take 1 out, it's 14 now. It's 14 divisible by 4? No. Is 13 divisible by 4? No. But is 12 divisible by 4? Yes. So I'm gonna take 12 here out of the 15 and put it over 4, and I have a number left over 4 as well. Okay, if I took 12 out of 15, how many do I have left? 3. So it's 12 over 4 and 3 over 4. Which number, if multiplied by 4, gives me a 12? It's 3. So I'm gonna have 3 instead of this 12 over 4 and have the 3 over 4 glued to it. Okay, is this the simplified form? Yes, it is, because the difference between the 3 and the 4 is 1. Okay, now if I'm multiplying fractions by fractions, okay, let's take a look at this example. I have a 1 over 2 multiplied by another 1 over 2. How do I do that? This is very simple as well. Okay, I'm gonna multiply the denominators by each other and the nominators by each other. That means I have 1 multiplied by 1 in the numerator and 2 multiplied by 2 in the denominator. What does that give me? 1 multiplied by 1 is 1 and 2 multiplied by 2 is 4. So the answer is 1 over 4. Is this the simplified form? Yes, because I have 1 in the numerator. Okay, what about this example? I have 2 over 3 multiplied by 1 over 2. Okay, same thing. Multiply the nominators by each other and multiply the denominators by each other. This gives me a 6 in the denominator and 1 multiplied by 2 is 2. Now, is this the simplified form? No, it's not. Okay, how do I simplify it? 2 and 6. Which timetable do 2 and 6 meet as products? Timetable 2, which means I'm gonna divide by 2 up and below. Okay? Which number, if multiplied by 2 gives me a 2? It's 1. We already said that many times now. And which number, if multiplied by 2 gives me a 6? Is 3. So the answer is 1 over 3. Okay, here we're going to talk about multiplying fractions by fractions, but we're going to use something called cross-canceling. Okay, if we ever stumble upon a multiplication of fractions that goes like this, 2 over 5 multiplied by 5 over 7, you have to ask yourself something. Here I have 5 down, and here I have 5 above. So here there is 5 below, and here there is 5 above. And we are multiplying, right? Okay, so cross-canceling tells me that I can cancel this one out with this one and get the 2 over 7 only. These are the ones that survive. So 5 above cancels a 5 below, okay? And I still have 2 and 7 left, 2 above and 2 and 7 below. So this is my answer. Now, is this the simplified form? 2 over 7. Do 2 over 7 ever meet in a timetable? No, they don't. So this is the simplified form. Okay? Let's take a look at this one. I have 3 over 4 multiplied by 4 over 9. Okay? Let's look at our nominators and denominators. Here I have a 4, okay, below, and here I have a 4 above. Okay? And we are multiplying. That means I can use cross-canceling. I can cancel this one with this one. Okay? And those that survive are the 3 above and the 9 below, with the line in between. Okay? Now ask yourself, is this the simplified form? No, it's not. Do 3 and 9 meet as products in any timetable? Yes, they do. Which timetable? 3. So I'm gonna have to divide by 3 above and below. Which number, if multiplied by 3, gives me a 3? It's 1. And which number, if multiplied by 3, gives me a 9? It's 3. So the answer is 1 over 3. Okay, now we're gonna talk about dividing fractions. Okay, we have two cases. If fraction comes first, or if the whole number comes first, or if I'm dividing by another fraction. Okay, let's take this case first. If fractions come first, like if I have a division problem, okay, I'm dividing fractions by a whole number, and the fraction comes first, and then the whole number, like this, and this one, okay? What do? This is very simple. Whole number gets multiplied to the denominator. Remember, in multiplication, we used to multiply the whole number to the denominator. Now we're gonna go the other way around. We're gonna multiply the whole number to the denominator, okay? And if we do this, this denominator stays the same, and the denominator becomes 2 multiplied by 6. What's 2 multiplied by 6? It's 12. It's 1 over 12. Is this the simplified form? Yes, because I have a denominator of 1. Okay? What about this one? 1 over 2 divided by 2. The whole number goes to the denominator, and the denominator stays the same. So it's 1 over 4. Okay, is this the simplest form? Yes, it is, because the denominator is 1. Okay, let's take this case. If whole number comes first, or if I'm dividing by another fraction. Okay, we're gonna use something called KFC. Okay, keep, flip, and change. Okay, how does this work? Here I have the whole number first, and then the fraction. How do I do that? Okay, I'm gonna use K, F, and C. Okay, this means I'm gonna keep this number as it is. Okay, I'm gonna flip this one, 1 over 4. I'm gonna flip it the other way around, so it will become 4 over 1. What's any number divided by 1? It's itself, so I'm gonna neglect this over 1, okay? And I'm gonna change the sign, the division sign, I'm gonna turn it into multiplication. So now I have 6 multiplied by 4. What's a 6 multiplied by 4? It's 24. So the answer is 24, okay? Let's take a look at this one. I have 5 divided by 1 over 6, okay? Apply the KFC, keep this one, flip this one, and change the sign, okay? So I'm gonna keep the 5 as it is. I'm gonna flip the 1 over 6, so it will become a 6 over 1. What's a 6 over 1? Still a 6. And I'm gonna change the sign in between. So now it becomes a 5 multiplied by 6. What's a 5 multiplied by 6? 30. Okay? Now here I have 1 over 2 divided by 1 over 4. Okay? Two fractions divided by each other. I'm still gonna use the KFC. I'm gonna keep this one, flip this one, and change the sign. So I'm gonna have 1 over 2. Okay, I'm gonna flip this one, so it's a 4 over 1. Okay, and I'm gonna multiply. I can neglect this 4 over 1, or I can keep it either way, it's not gonna matter. Okay, because now I have a fraction multiplied by a whole number. In the multiplication case, the whole number goes to the denominator, right? So now I have a 4 over 2, okay? Okay, what's a 4 over 2? 4 divided by 2. Which number? If multiplied by 2 gives me a 4, it's a 2. So the answer is 2.